Hello everyone, my name is John Andresakis. I am the Director of Business Development for Quantic Ohmega, and I'd like to give you an update here from the IMS show in 2023 in San Diego. What we do at Quantic Ohmega is make a resistive foil. So we take a copper foil that is used in the industry for making printed circuit boards, and on the back side we actually put a resistive element. So we have two flavors. We have a nichrome and we also have a nickel phosphorus, and they both supply different properties, but the intent is to make a resistive element on a printed circuit board. So it utilizes basically a two-step process. So we take our film and we put it on a laminate structure, and this can be on any laminate that the customer wants. So it could be on a very high performance laminate like a PTFE from a Rogers or AGC Multi-Materials, or it can be on a standard FR4 epoxy. We cover a wide range of materials. So it gets laminated as a core, and then it goes through an imaging process very similar to making an inner layer in a circuit board, where you go ahead and you first define where the copper and resistors are going to be, and you remove the background material, the background copper and the background resistor material you don't need. Then you go through a second imaging step, and this one's in an acid environment, so we attack everything. Here we use an alkaline environment, and so we only attack the copper but leave the resistor behind. So by doing a selective etch process, we could take it from a base laminate, which is your blank slate, and take it to making finished resistor elements. The nice thing about this material is that by using different geometries, you could use one sheet of resistive material to get multiple resistive ranges. So we can have the same material be a 10 ohm resistor or a 1000 ohm resistor. And it all has to do with the ratio of length to width. So if your length is 10 times longer than your width, you're going to get 10 times the resistance value of one that's just one, let's say a 1 square, which is, let's say, like 1 millimeter by 1 millimeter. It would be the same if you go 10 blocks now, it would be 10 resistance higher. And so also you can, if you have limited area, you could do a serpentine pattern. So we have examples of that where you can go ahead and make a very high resistive element, and you'll see this a little bit better, but by serpentining your resistor, you make a very long length in a very small area. And so that'll give you a high resistance value. The material is very versatile. The one thing we also found is, besides being for resistors, like let's say you put them in circuit boards and you get rid of those surface mount resistors, which is the real value proposition for this product, you also get better high frequency performance, because you no longer have to go up through the via to a solder joint, through the resistor, and then back down again. And so it gives much better high frequency response, as well as miniaturization and lightweight. But because it's a resistive element, it could also be used in frequently selective surfaces. And so we have cases now where people can pattern it and use it as the resistive element for a particular pattern, depending what frequency that you want a response to. Here's an example where it was used as a resistor card, and we're able to get a much better definition of the frequency of choice and get rid of the background noise, and to also do the narrowing of the band. So this is a classic example of how to use our material. The other thing too for the RF microwave world is for things like power combiners and dividers, because you usually have to solder a little resistive element in between your junctions. This way you can make a planar resistor and get rid of those surface mount components, so you can make actually now a two-dimensional power divider and not have to worry about height. So it gives you much more flexibility in design. So we're also starting to showcase our new products, which we're working on, which is the very smooth copper foil. As you go to higher frequencies, the profile of the copper foil becomes very critical. And so we're working on, we have one product already now called TCR EHF, and that is for very high frequency because it has a very low profile copper. We're now working on even smoother coppers to get even a better frequency response. The other thing we're also working on is that for cases where you need a very thin copper layer, where you're going to be doing some very tight lines and spaces, we have a release carrier copper where it's only 3 to 5 microns of copper with a ½ ounce carrier. So you laminate it to your surface just like this, and then you would go ahead and take the release layer off, and you're left with 3 to 5 microns of copper, which now allow you to plate up your traces and make very fine features. And we would now sputter our resistor material or plate our resistor material onto the back of that 3 to 5 mine copper. So now you can make it very, very fine features, like for chip packaging or some very tight lines and spaces for your different applications. Our major location is in Culver City, California, but we also have operations in Windsor, Connecticut, and in Chandler, Arizona. We've been in business now for over 50 years. And we have a long history of having very successful projects, especially when it comes to mission critical, because we have been in space now for quite a long time. We have material that's on Mars, we have material that's out in satellites and in a lot of critical applications because it's very robust, it has a very high reliability, and so designers have come to use it for those type of applications. Now that we're part of the Quantic family, that gives us even more reach because we can work with our other, other sister divisions, other sister companies to further extend the reach of our product and also to rely on their expertise in the RF microwave world to help us guide what type of products we should be working on and which companies we should be dealing with. So please, check out our products at our website. And again, my name is John Andresakis, and I appreciate your time. Thank you.